Guys, this is the 2015 free response question number 6. So we're given this curve, y cubed minus xy equals 2, and we're given this differential equation. In part A, we're asked to write the equation of the tangent to the curve at the point negative 1, 1. So we know we need two things. We need our point, which is negative 1, 1, and we know that we need our slope. And the slope of the tangent line is just the derivative evaluated at that point. So we're going to plug negative 1, 1 into our equation here, into our differential. So it's 1 over 3 times 1 squared minus negative 1. And so we get 1/4 for our slope. So the equation of the tangent line is going to be y minus 1 equals 1/4 times x plus 1. This was worth 2 points. It was 1 point for actually getting your slope, so that 1/4, and then 1 point for the equation of your tangent line. Part B here, we're asked to find the coordinates of all points on the curve at which the line tangent to the curve at that point is vertical. So we know if we're looking at a tangent line being vertical, it means that the slope is undefined. Well, in order for the slope to be undefined, we must be trying to divide by 0. So if we look at our equation here, the denominator is 3y squared minus x. So we want to know when is 3y squared minus x equal to 0. If we can find the coordinate points where that happens, then we would know that the slope is undefined. So in order to do this, let's see, if I add x to the other side, I have 3y squared is equal to x. So I've got this equation here, but now I need to solve it, right? And I only have one equation, but I have two variables. So what I have to think about is the other equation that they gave me was the equation of the actual curve. So it's y cubed minus xy equals 2. So this is the actual equation of the curve. Well, what we're going to do is hopefully you notice that this says x equals. So we're going to take this 3y squared and we're going to plug it in for this x value right here. So what I'm going to do then is y cubed minus 3y squared times y is equal to 2. So again, what I really did here is I noticed that there's an x here and an x here, and I'm going to use substitution. So the 3y squared that I'm plugging in is really going right here in that equation. And now I can just solve for y, because now I only have one variable. So remember, in order to solve a system, you need two equations. That's why we had to use this original curve that they gave us also. So we have y cubed minus 3y cubed is equal to 2. So negative 2y cubed is equal to 2. If I divide by negative 2, I get y cubed is equal to negative 1. And then if I take the cubed root of both sides, I get y is equal to negative 1. Now this equation asked us for the coordinate points. So not just for the y value, we need to find the x value also. So what I'm going to do then is I'm going to go back to this 3y squared equals x, and I'm going to plug my negative 1 in. So I have 3, and I'm going to plug my negative 1 in, and so I get that x is equal to 3. Oops, this should be squared. That's why the negative cancels out. And so our final answer then is going to be the point 3, negative 1. At that point, the tangent line is going to be vertical because it would have an undefined slope. If we were to plug 3, negative 1 into this differential equation up here, we would get an undefined slope. This was worth 3 points. So it was 1 point for actually setting your denominator equal to 0. It was 1 point for getting it down to one variable so that you could solve. So that's like this part right here where we only had it in terms of y, and then 1 point for your answer. Part C here asks us to evaluate the second derivative at the point on the curve where x is -1 and y is 1. Well, in order to evaluate the second derivative, we're going to have to actually find the second derivative, which means take the derivative of the differential equation that we were already given. So we notice here we're going to need the quotient rule, and we're going to need to use implicit differentiation because there's y's in this equation as well. So d2y over dx2 is going to be equal to, and I'm going to draw a big line here. So we know it's low d high, so low times the derivative of the top. So 3y squared minus x times the derivative of the top, which is dy dx. That's our implicit right there. Minus the top times the derivative of the bottom. So we're going to have 6y dy dx. Again, there's that implicit, minus 1. And then all over the bottom squared. So 3y squared minus x quantity squared. So this is our second derivative, all right? Now you'll notice that this second derivative has this dy dx in here, and it actually has it twice. So what we're going to need to do is we're going to need to substitute in our stuff here. So let's do that. Now we have to remember that in part A, we found the slope at -1, 1. We found it to be 1/4. So we don't have to do all of that work again. So what I'm going to do over here then is on the side, I'm just going to write us a reminder that we already got dy dx to be equal to 1/4. So those two places that I highlighted already, we're going to go ahead and just use that 1/4. We don't have to plug in the derivative in here and simplify it down. We don't have to find it again. So we kind of luck out. This is a little bit easier than if they just wanted the derivative. So now let's go ahead and evaluate it at the point -1, 1. So let's see, we're going to have 3 times 1 squared minus -1 times that 1/4. And then minus, let's see, y is 1. So 6 times 1, and we get that 1/4 again. And then minus 1 all over 3 times 1 squared minus -1 all squared. And now we need to simplify that. So d2y dx squared evaluated at -1, 1 is going to be equal to, let's see, we'd have 3 plus 1 is 4 times 1/4 is going to be 1. Minus, let's see, 1 times, that would be 3 over 2 minus 1, all over 3 plus 1 is 4, so 16. So let's see, we get 1 minus 1/2 all over 16. So we get 1, let's see, 1/2 over 16. And so we get 1 over 32 as our answer. So d2y dx squared evaluated at -1, 1 is equal to 1 over 32. All right, there we go. So this one was worth 4 points total. So it was 2 points for your derivative and for using that implicit differentiation. It was 1 point for substituting in that dy dx, which we already found, so we were lucky there. And then it's 1 point for your actual answer. If you have any questions on that one, I know that one was a little weird. That's something that we haven't really done before. So if you have any questions, please make sure you reach out and ask your calculus teacher.